આમાં તમે કેટલા વધારે 20 લાખ વધારે ના ઓગસ્ટના જોતે ને આજે 12 ઈ દેતા કે આ ચીકરા તો આવી ગયા દીમાં આવે તો તમને આ કેટલા 27 આમાં શું જોઈ એમાં પછી ઓલું 2% વાળું ઇન્સેન્ટિવમાં આવી જાય મારે કાઉન્ટિંગ કરી નાખ્યું
Good evening, everyone. आज બધા ચા પીને આવ્યા છે ને સુઈ નહીં જતા આજ હોમવર્ક થઈ ગયું કે નહીં
આ વખતે 2 લાખ જેવું આ કાઢ્યું ગઈ વખતે 15
સારું રીતે નો ભાવે તો
એ બધું
ચા પીવાય જ નહીં
બાકીમાં તો
Srishti, you are writing in Hindi. Okay. Good evening, everyone. Especially the newcomers. Okay, so let's continue now with the second chapter. Right. Last time we were solving some exercise questions. Okay. So we solved this question and then we were solving those exercise things, right? Okay, we did it from the first chapter. Okay. So now we are going to the exercise of chapter 2. Right? We are going to the exercise of chapter 2. Right? And I asked you to solve 21, 22 for homework, right? Okay, so today we are going to solve question 15, 1 5. We are going to solve question 15, right? Okay, let's start. See, we will definitely use things that we have learned yesterday. All right, so I hope everyone is ready. Okay, so here is the question 15 from the exercise on your screen. a spherical conducting shell of inner radius r1 and outer radius r2. Remember, it's a spherical conducting shell, right? Okay. Himani, is it okay if I do it at the end at 4:50? All right. Okay, so we will draw the diagram, right? So here is that spherical shell. Its inner radius is r1, I think, and outer radius is r2. Good afternoon, Aman. Okay, now it is given a charge q. It is given a charge q. Okay, so where will that charge q, capital Q, be? Where will this charge q be? Come on, where will the charge q be? On the outer surface, right? Yes, on the outer surface. So first of all, you have charge q over here on the outer surface, right? Okay, I hope you remember all that, right? We have spent a lot of time talking about properties of conductors, right? Okay, now let's read A part. A, a charge Q is placed at the center of the shell. Okay, so now what is done? What is done? I'm going to reuse the same diagram. Over here at the center of this shell, we are putting a charge Q, right? We are putting a charge Q, right? So I hope you remember that these charges will change. That is, the charge distribution will change, right? Okay, charge distribution will change, right? So now the question, how much charge will come on inner surface? Come on, people, how much charge on this inner surface? Everybody, how much charge will come on the inner surface? Hmm, minus q and 0 શું છે? 0? No. No. If you will put this charge q here, then on this inner surface there will be a negative charge attracted, right? Opposite of q. So on this inner surface there will be a charge minus q. All right. Okay. Yes, Avinash. Okay, so this is what array answer ni bahut our fine. Now next question, if once you put this here, right, this is A part, we put this charge q here. Now how much charge will be there on outer surface? Come on, how much charge will be there on outer surface? Yes. No, Ramya. Others, your answers are right. No, Vishwa. No, Harsh. No. Yes, they will. Correct answer. Yes, Harshad. Right answer. See, total charge on that shell. On means held by the shell. All right. I hope I don't have to explain this again ever. Right. Total charge held by shell is equal to capital Q, and on inner surface it is minus q, right? So if I call this x again, right, then x plus minus q is equal to capital Q. That's why x will be q plus q, right? I hope nobody has any doubt whatsoever. So now it will become q plus q. First it was capital Q. That's okay, that's old now. If you put this q here, this will become q plus q. Okay, right? So now let's solve the question. The question says surface charge density. Yes, now what's the formula of surface charge density, everyone? Hurry up. Surface charge density. Q by A, right? Hey, Purvendra, શું કરે તું આ? People, I'm asking about surface charge density. Okay, not line or linear. I'm not talking about linear. So it's not dq by dl or q by l. No, this is q by a or dq by da, right? Okay, so find the answer. Hurry up. Find the answers. Find the answers. After 1 minute, we will go to next question, next part, that is B. Hurry up, come on. What Q won't come? Sorry, I don't understand what you're saying. Okay, Sorali, I wrote this just for indicating the formula of surface charge density, right? That's it, nothing else. Okay. I didn't mean it in context of this question that Q or capital Q, all right? Not in context of this question. All right, so answer for inner surface is going to be sigma 1 equal to minus q divided by 4 pi r1 square, and for outer surface is going to be sigma 2 equal to capital Q plus q upon 4 pi r2 square. All right, any questions, anyone? Any questions? r1 r2 લખજો બે અલગ છે. Any questions, anyone? Okay. Fine. So we're going to the next one, B. So B says, this is a theoretical question only, very easy to do. Is electric field inside cavity with no charge? No charge means charge free cavity. હવે ડેન્ટિસ્ટ પાસે જાઓ ને કેવિટી હોય તો પૂછતા નહીં ડેન્ટિસ્ટ ને, is it charge free? So is electric field inside a charge free cavity zero even if shell is not spherical? What do you think? Shape બીજો હોય તો? ચૈત્ય કાલ સમજાવ્યું તું, હવે તું પર્સનલી પૂછી લેજે. કાલ આખો કલાક Q પ્લસ Q માં તો કાઢ્યો તો યાર. Yes, it will still be zero, right? Shape does not matter, right? If it is charge free cavity, then electric field in that cavity will be zero, right? Yeah, this chapter is electrostatics only, Himani, so that's okay, right? Fine, so that's it. Now let's go to the next question. So this was 15. We'll do 16 later. Okay. 17 is homework. Question 17 is homework because 17 is actually from the first chapter. They have put it over here by mistake. All right. 17 is homework. એનો ખાલી ડાયાગ્રામ ડ્રો કરી દઉં તમને, પછી બાકીનું તમે કરી લેજો જાતે, રાઈટ? અત્યારે એમને એમ ડ્રો કરવો હોય તો કરી લો ક્વેશ્ચન વાંચ્યા વગર. 17 નો ડાયાગ્રામ ડ્રો કરી દઉં છું. This is diagram for question number 17. These are two coaxial cylinders. Coaxial નો મતલબ થાય same axis, right? So you can see they are both on the same axis. આવી રીતે હોય ને એને કહેવાય coaxial, right? So that's what this question is about, right? પછી આવડી જાય છે ખરેખર ગોસ લો કરશો એટલે તરત જ આન્સર આવી જશે, બહુ કઈ લાંબુ નથી. એક ડેરિવેશન કર્યું હતું ને ઓલું સ્ટ્રેટ વાયરનું, એના જેવું છે. ઓકે, સો આઈ થિંક યુ શુડ ડુ ઇટ ઓન યોર ઓન. Alright, so 17 is done. 18 now. Okay, let's solve 18. Okay. Number 18. In hydrogen atom, electron and proton are bound at a distance of 0.53 angstrom. See, you have studied little bit in chemistry. I know we have not done this in physics yet, but તમને એટલું તો આવડે ને કે suppose this is the proton P and here is the electron, right? Okay, then this electron revolves around the proton or something like that, right? Basically they are bound means they cannot get separated on their own, right? Okay, યાદ છે ને binding energy from gravitation. Okay, so the distance is given. How much is the distance? 0.53 angstrom. Estimate potential energy of system in EV taking zero of potential energy. Zero matlab reference. Taking reference of potential energy at infinite separation. EGPG, isn't it? બહુ ફાલતુ ક્વેશ્ચન છે ને. શું ફાઇન્ડ કરવાનું છે? What is to be found? બોલો જલ્દી. What is to be found? પોટેન્શિયલ એનર્જી, બરાબર. અને રેફરન્સ એ ઇન્ફાઇનાઇટ, એટલે આપણી ફેવરિટ સિચ્યુએશન U is equal to K Q1 Q2 by R, right? Okay. Yes, Darshi, you're right, but there is no need to make it so complicated, right? These are just 2-point charges. All right, these are just 2-point charges, right? And if we take a reference at infinity, we can always use this formula, right? What you are saying is correct, but this is very simple, right? Okay, so we can just do it. Now one thing, it is said that you have to find this in EV. અચ્છા, કોઈને આવડે છે જૂલ EV નું relation? one EV is how many joule? 1 EV is how many joule? How many of you know this? How many of you know this? Tell me that. How many of you know that 1 EV is how many joule? No, Darshi. No, Aman, that's wrong. Okay. Yes, this number is same as magnitude of charge of electron, right? બરાબર ને? 1.6 into 10 raised to minus 19. બસ, તો આ જે આન્સર આવશે ને એ જૂલમાં આવશે, બરાબર? ઓકે, પછી એને કન્વર્ટ કરી નાખજો. ફાઇન, કેલ્ક્યુલેટરનું કામ છે. 1 એંગસ્ટ્રોમ તો આવડે જ ને બધાને, કે મૂકી દઉં 11th માં પાછા? એમાંય ચાલી ગયું હવે તો. સો યુ આર આઉટ ઓફ લક. બરાબર છે, 10 raised to minus 10. Okay, so that's it, right? This is how you can do it. Clear? એક કામ કરો ને, કરી જ નાખો. ચલો, find it everyone. Do it and tell me the answer. Chemistry નું ગોખેલું હોય તો એ બોલી જજો, કઈ વાંધો નહીં. ના, 27.2 EV નો આવે. નો આવે 27 point. Okay, yes, sorry. You're right. I made a mistake. હું half કરતો તો આમ. It's right. Well done. So it is minus 27.2 E. Thank you. Okay. Now let's read part B. What is the minimum work required to free the electron given that its kinetic energy in orbit is half the magnitude of potential energy obtained in A? આવું તો gravitation માં આવતું હતું, યાદ છે? For satellites we used to have that k is equal to minus u by 2 which is equal to minus E. યાદ આવ્યું ને? Okay. Anyways, right, what we are given here is that k is equal to minus u by 2, not just for satellites, also for electron, proton. Sorry, electron, not for proton. Then we have to find what is the minimum work required, right? We have to find what is the minimum work required. Minimum work, how much energy you need to give, right? What is the minimum work required to free the electron? આને શું કહેવાય? What do you think this is called? This has a very nice name. What is it called? Hey, delocalization of E no કહેવાય આને. Physics language, everyone. Yes, Avinash, your answer is right. Work required to free electron તો મેં લખ્યું છે ધવલ, તું ઈ નહીં લખે. Delocalization is anyway something else. ભૂલી ગયા હો બધા. Think of it like satellites. W external. વાહ વાહ. આ શું લખ્યું છે અહીંયા? વર્ક તો લખ્યું છે ને, તું ખાલી વર્ક લખીશ. It is called binding energy. યાદ છે ને? Binding energy. Binding energy means minimum energy required to be supplied, right, to break the system. Yes. Or see, if you have forgotten all this, no problem, you could read it. It has been explained by me in gravitation. Here I can do it like this. See, we want to find out how much is the external work to separate everything, right? So that is obviously equal to delta k plus delta u, right? But we want to find the minimum work. So if you want to find the minimum work, you should put delta k as equal to 0. All right. Okay. Or actually even worse, you should put final kinetic. Sorry, just a minute. I'll just take it back. See, this is how it is going to turn out. Right now this electron might be moving. It will have some initial kinetic energy, right? So when you send it to infinity and you send it with 0 kinetic energy finally, right? Okay, we want the electron to be very slow. We don't want to give it kinetic energy also, right? So if you do it by energy conservation or by using this formula, ગમે તેમ કરો, right, this is what you will get. All right, this is 0. Why is it 0? બરાબર ને? You no, अरे હું ઉતાવળ કરી ગયો. Just a minute. No, no, just a minute, just a minute. I just said it wrong. Excuse me. Excuse me. I'm trying to rush too much. Okay. Finally, this electron is at infinite, right? Finally, this electron goes to infinity, right? So that's why U final is 0, all right? U initial તો આપણે find કરી છે ને, initially electron is here and we want to throw it out, right? Okay, so U final is 0 because that is at infinity, minus U initial you have already found, final kinetic energy is 0, and what is initial kinetic energy? Half of potential energy in value. Did you understand this step? Is this clear? Yes or no? It, all right. I would just say that if you would be remembering it for satellites, we had that the, listen to this, we had that the total energy of satellite is E, right? Mechanical energy is E, right? And binding energy is always negative of E. I think I made you write this as well, right? Correct? So in that case, this question would be very simple. Because binding energy is minus E, that is nothing but the answer of this question, right? Minimum external work, right? That is equal to minus E. If that is minus E, and I'm sure you remember that E will be equal to K, E will be equal to minus K, or you could say E is equal to U by 2. Okay or not okay? Right? So then this is simply minus 27 point, minus 27.2 by 2, right? That is equal to 13.6 ev. All right, I hope this method is also clear, right? Because this is very short, right? એક લાઈનમાં પૂરું થઈ જાય, એક જ વેલ્યુ મૂકો એટલે આન્સર આવી જાય, right? Okay, પણ આના માટે ઓલું ગ્રેવિટેશન વાળું યાદ હોવું જોઈએ. Anyways, you know what, you are going to learn this in chapter atoms also, right? So if you can remember this, it will be helpful, right? We are going to do such things in chapter atoms again, right? Okay, fine. So I think that's enough for B, right? Let's go to C. What are the answers to A and B above? If 0 of potential, again 0 means reference, right? If reference of potential energy is taken at 1.06 angstrom separation. Okay, now this question really deserves special attention, because otherwise it might confuse you out. Okay, so what is given is that if we now take the reference not at infinity, right? Now reference is not at infinity, but we take it at some distance 1.06 angstrom separation. So what that means is, this is proton, all right? Here is electron, which is actually at a distance 0.53 angstrom. But if you would take this point here as the reference, right? So that distance of that point from this proton would be 0.5, 1.06 angstrom, right? So let's call this point B, okay, and let's call this point A. So electron is revolving maybe at A, right? But the reference point is at B. So UB equal to 0 or VB equal to 0, as you like. All right. Is this question clear? Is this situation clear? શું કરવાનું એ સમજાવજો એક, right? Okay. Now the question says we have to find what are answers of A and B again, right? So this time we have to do this by taking reference at that point B. All right. Now let's start with this. Okay. I hope all of you remember that you can take reference anywhere. You can take reference anywhere, but the change in potential energy, right, or change in any kind of energy will not depend on reference, right? Okay, so that's why the answer of B will be same. All right, the answer of B will be same. Is this clear? Yes or no? Words માં એવું લખી નાખવાનું એક્ઝામ માં તે, right? You just say that changes in energy don't depend on where is reference of potential energy, right? I'll repeat, changes in energy or work, right? This work should not depend on where is the reference of potential energy. So that's why the answer of part B is same. જે ઓલામાં આવતું હતું ઈ જ આવ્યું ફરીવાર. Okay. For anyone who would like to understand this better, I'll just explain it in one line. See, you can write it like this. Okay, clearly kinetic energy does not depend on reference, right? And delta U also does not depend on reference. So what I'm saying is that this external work does not depend on reference, right? So that's why answer will remain same. All right. So now let's go to A part, which is actually crucial, right? So now for A part, we'll have to look at this diagram. This is reference point, and this is the position where the electron is. So we want to find what is its potential energy. I mean, what is the system's potential energy, right? Okay. So what we have to do is, there are two ways to do it. One is by integration. The other one is by using this very idea, right? What idea? Happy about this sentence, right? We can use it. So let's see how. Case 1. Case 1 means reference at infinity. All right. Clear? Okay. This should be equal to case 2, reference at B. Is this whole line understood? I'm really concerned about it. બહુ જોરદાર છે, એકદમ સિમ્પલ, પણ આ તમને સમજાય ને તો આગળ સાવ ઈઝી પડે. Again, let me start with this sentence. Have you understood this one first of all? That delta U does not depend on reference. Okay, some of you said no, so that's why I'm asking again. Do you all remember that delta U does not depend on reference, right? That is, change in potential energy is always fixed. ભલે potential energy ગમે ત્યાંથી લીધી હોય, reference ગમે તે લો, right? So then in first case we took reference at infinity. Then we get, suppose for B we get potential energy VB, and for A we get potential energy UB and UA. All right, we get UB and UA. And now in case 2 we take reference at B, then we get potential energy for B is UB dash, dash means second case, and potential energy for A is UA dash. All right, better now? Have you understood this time? If you still have not understood, don't worry, I will show the other method also. All right, okay. Will they be equal? Don't use pronouns, Sorali. Who is they? Things are equal. Yes, these two will be equal. That's why I'm writing equal to here, right? If I am talking about these two differences, then these two will be equal, because delta U does not depend on reference. You can take any reference, the value of difference will be same. Now let's start putting everything, right? You know, the advantage of reference at B is not understood, that is given in question, Hertz. It is written that you take reference over here. So that's why we have taken reference over here at this point B, which is at distance 1.06 angstrom. Okay. So now UB. See, we are taking reference at infinity, so we can use our favorite formula. All right. This we have already found, by the way, right? This one we have already found. We have already found UA, correct? I don't know the answer, Kia. All right, is equal to 0 reference. Okay. Right? Is this step clear? I want to know, people. Okay. Now, what's this term that we already know? It is minus 27.2. બરાબર ને? એ જે હતું ને પહેલા ફાઇન્ડ કર્યું હતું, right? So what will be this term? Can you tell me? અરે આ denominator જો એટલે જ મેં આમ લખ્યું છે. It's very easy to do if you look at the denominator. Yes, at infinity potential is 0. આ લેફ્ટ સાઈડ નું ચાલે છે, રાઈટ સાઈડ નું નહીં, ચૈત્ય. On right side potential is at B. On left side potential is at infinity. So this is going to be minus 13.6. બરાબર ને? ઓકે, તો બસ હવે આ સબટ્રેક્ટ કરી લો તો ઓકે, જસ્ટ મિનિટ, સોરી, just subtract this, so you get your answer. પતી ગયો સમ. All right, okay. So what will be this answer? UA dash will be equal to right, minus 13.6 EV. Yes, KI, your answer was correct. Okay, now yeah, let's do the other method. Sir, at reference B, how is it 0? Chaitya, meaning of reference is potential energy is 0, right? It's a basic definition છે, 11th માં આવી હતી. Okay. No, it will not be plus. કે the plus થાય, અહીંયા minus sign છે. Okay. Right, let's go to the other method. જેમને આ મેથડ માં બહુ મજા ન આવી હોય, ઇન્ટિગ્રેશન માટે તૈયાર રહેજો, પછી કહેતા નહીં. Okay, now I'm just going to select all this so that I don't have to draw it again, right? Okay, so that part is common, right? એટલું તો લખવાનું જ છે, એટલો ડાયાગ્રામ તો ડ્રો કરવો જ પડશે. Okay, now see, if you want to find what's the potential energy at this point A, then we use basic definition. All right, આ બધું કઈ કામનું નથી. Then we will use basic definition. Okay, so what's that basic definition? Integration વાળી formula છે ને potential energy ની. U is equal to negative integration fe vector dot dr vector from infinity to that point A. યાદ છે બધાને? I hope you all remember this. Okay, so now let's do this. What's the force acting between these two? One is proton, the other is electron. So the force will be Ke minus E divided by R square R hat. All right. R hat લખવાનું ને, radial direction. Okay. So now minus integration. Okay, see the difference. Just a minute. Before we go ahead, we used to write this because we took reference at infinity, correct? Okay, right? But now we are not taking reference at infinity, so I'm just making a small change. This is actually better, right? I hope you remember this one as well. Okay, so now instead of dr vector we should write dr r hat, right? Okay, so now r hat dot r hat will be 1, and then we have to put limit from B to A. I thought I erased everything below this, but I was wrong. Okay, now on left side, remember here we have reference not at infinity but reference is at B. Can we do it by W external? No. How will you put K's value? How will you put U's value? Right? You don't have all the values, Rupa. That's why you can't do it like that. So let's continue. What is UB, everyone? What is UB? What is UB? Read this. Okay, thank you, hello, 0. All right, so UA minus 0 is equal to this. હવે integration કરવાનું છે. Okay, constants outside, minus minus plus KE square constant, right? What's remaining inside is r hat dot r hat is 1, so ખાલી થઈ ગયું dr by r square, right? અને એનું integration કરવાનું from B to A. B means how much distance? 1.06 angstrom, and A means how much distance? 0.53 angstrom. All right. Okay, આવું બધું ન લખવું હોય ને તો શું લખાય ખબર છે? RA RB makes it very easy to calculate and put the value at the end. All right. હવે કરી લેશો ને for the second method. All right, everyone. Should I leave it here? ઇન્ટિગ્રેશન કરવાનું છે અને વેલ્યુ મૂકી દેવાની એટલે ઓલો આન્સર આવી જશે. લેફ્ટ સાઈડ તો UA થઈ જ ગયું છે. See, why did we do integration from B to A? Because B is reference. એટલે અહીંયા 0 મૂકવા થાય. Understood? Because B is reference, we took B over here. Generally infinity reference હોય ને તો આપણે અહીંયા infinity લખતા હોય. Correct? Okay then. This is easier. All right. મને તો આમાં કેલ્ક્યુલેશન કરવું પડ્યું એવું લાગ્યું. Right? This is very short. Look at this. આ નંબર ખબર છે, આ નંબર આના હાફ થાય, પતી ગયો સમ. આવી ગયો આન્સર. Isn't it that simple? I would go with the first way. Personally, I would go with the first way. I find it is very short. That's it. Right? બીજું કાંઈ નહીં, એમાં કાંઈ સારું ખરાબ કાંઈ નથી. Right? Both are okay. But this is it. Right? યાદ છે મેં તમને કીધું હતું કે 11th ના જે પહેલા ચેપ્ટર છે અપ ટુ 6, રાઈટ, એ કોઈ દિવસ પીછો ન છોડે. I think you would understand why I was saying that at that time. Right? આ રેફરન્સ ને પોટેન્શિયલ એનર્જી ને બધું હજી છેક સુધી આવશે. બરાબર ને? અહીંયા પૂરું નથી થતું, હજી છેક સુધી નડશે. So you must revise it. If you remember, I was teaching it so slowly so that you would understand what is reference and everything at that time. ત્યારે તમને એમ જ થતું હશે સર કેટલું લાંબુ લાંબુ ભણાય, પણ આ બધું યાદ રહે તો અહીંયા કામ આવે એવું છે. Yes, I will not. Okay. Now, 19th question is homework. All right, everyone. 19th question is homework. Okay. I'm actually tempted to do 20, but we'll save it for later. There has been a question about 22, right? That was given for homework. So I'll just give you some hints about that. Yes, 22, right? Okay, so we are going to do 22, right? Those who have completed it, right? If you want, you can save this time, 10 minutes or so, and try the question number 20. All right? Okay, we will not do it today. We will not solve question 20 today. We will do it tomorrow. All right? Okay, so 22 now. Those who don't want to see 22, you may leave, no problem. The class is over. Okay? Take a break. આંખ બંધ કરીને બેસો થોડીક વાર. સવારથી સ્ક્રીનની સામે જોઈતા આવજો. Okay. Now here the question is, figure shows a charge array. Array matlab collection or system. All right? So known as electric quadrupole. Dipole also, so the quadrupole. 4, right? 4 charges. Okay. For a point on the axis of the quadrupole, okay, here's that point P on the axis, right? I think I don't have to explain that this is called axis, right? It's very simple. Obtain the dependence. Dependence means relation of potential with R. એટલે formula derive કરવાની છે, right? We have to find what is V as a formula with R. Okay? Right. Now, that was the question. I believe now the question is clear, right? And then you have to compare. Contrast means compare with electric dipole and electric monopole. Monopole means single charge. અરે ડાયપોલ ના તો બે ફોર્મ્યુલા આવડે જ ને. ડાયપોલ માં શું આવે? K P cos theta by R square, right? Okay, and for monopole means single charge, it is KQ by R. All right? Just like that, what is it for a quadrupole? You find કરવાનું. Question is clear, especially those who ask me about this. હવે આગળ કરી દઉં. I'll just write one line for hint. Suppose you call this A, B, C, and D, right? Then potential at P, Vp is to be found. Who will create potential at P? તો અહીંયા શું લખવું જોઈએ? બોલો. Vp is equal to what? Who will create potential at P? Answer no આવ્યો. I was waiting for your answers. Yes, Kia, correct. Remaining 3 points. અરે શિવાંગી 4 છે, 3 ક્યાં? Correct. A, B, C, D, right. So this will be potential at P due to A plus potential at P due to B plus potential at P due to C plus potential at P due to D. All right. Due to 4. A, B, C, and D. Clear? It's not a vector, right? So it's going to be quite simple. All right. So that's how you have to do it. Okay. થોડુંક આનું maths છે ને complicated છે. Don't forget to use this. So you see, wherever you see things like r minus a or r square minus a square or r square plus a square, આ બધામાં neglect કરવાનું. આની જગ્યાએ r square a r square, right? Okay. But yes, you cannot do it from start. Okay, you cannot do it from the first step, otherwise you will get 0 answer. All right. Okay then. Now, is there any other question that anyone would like to ask? We are going to spend these minutes solving your doubts if you have doubts, especially from the homework. I'm waiting for your questions. આજ તો સરે વહેલા છોડી દીધા, એવું તો ભાગ્ય જ થાય. તો બાકીના લોકો શું હવે ગપ્પા મારવા રાહ જોવો છો? આખો દિવસ ફોન સામે થાકી જતા હશો નહીં? કે બહુ મજા આવે છે? Exercise 14th question. All right, David. આજે સ્કૂલ 2 કલાકની. Okay. Right, we are going to solve question 14. Right, so if you have a doubt with that, મને હતું જો કે આમાં કોઈને ડાઉટ ન આવ્યો, કારણ કે આ બહુ લાંબો ક્વેશ્ચન છે. Avinash, the answer to your question is integration. Okay, Harsh, we'll do it after this. If we have time, we'll do it, right? We're going to solve question 14 from second chapter's exercise. Here is the question, and this is part B only, right? So you see, Deval, the problem is with part B is that this is 10 centimeter away from midpoint, right? So here is a dipole, I think. No, sorry, not a dipole, just two charges, right? So let's say that this is Q1 and here is Q2. This point is A, this point is B. Here is midpoint M. But where we have to find it in part B is 10 centimeter from this midpoint in a plane normal to line passing through midpoint. See, this is a complicated way of saying perpendicular bisector, right? Means this point P is on the perpendicular bisector. So this is perpendicular bisector, right? Like this. Okay. So somewhere over here. Ah, send it to me personally, Avinash. Okay. So if you want to find potential at this point P, then VP is VP due to charge at A plus VP due to charge at B, right? So it તો થઈ જાય ને, because that is only scalar, right? You don't have to worry about direct, right? ખાલી આ distance find કર લેવાનું. That will be by geometry. This is 15. અહીં સુધી, huh? This is 15. So by Pythagoras theorem you can find this, right? So that you can do easily. But electric field, I understand, is complicated because electric field is a vector. So આમાં જેવું ડાઈપોલમાં કર્યું હતું ને એવું કંઈક કરું, right? So this is 1.5 microcoulomb. This is 2.5 microcoulomb. So the field of this will be over here, EP1, and the field of the second one will be somewhere over here, EP2, right? Or EPA and EPB, right? Okay. So now you have to find result. But problem is that these are not equal in magnitude. So if you want to find resultant EP, so in vector form, of course, you can write it like this, right? So when you find magnitude of resultant, then EP is going to be under root EP square, EPA square plus EPB square plus 2 EPA, EPB cos theta, right? Theta is angle between these two. These two means this angle, right? So if you want to find that, you'll have to do a lot of effort actually over here. And it is that to find that angle first, you should find this angle, right? To find that angle, you'll have to find this one. This is theta by 2, right? Half angle due to symmetry. So e theta by 2 કેવી મળે? Theta by 2 માટે છે ને અહીંયા sin theta by 2 is equal to 15 upon hypotenuse જે કંઈ આવે. I don't know what the hypotenuse, but you find it, right? Then look at the table, right? છે ને table, log table ની અંદર sin ની find કરવાની. So what is value of theta by 2? You find it. From that you find theta. Okay. So from that you find theta. Once you find theta, then you have to find cos theta, right? I know it's a complicated process, right? Otherwise, if you don't want to do all this, you can use a trigonometry formula that math students would be knowing. Sorry, right? You can use this trigonometry formula. એમાં અડધું તો કરવું જ પડે. If you find this, then you can jump to that formula, right? And if you do that, then you will be able to get cos theta. Say the magnitude મળી જાય, right? Okay. Finding these magnitudes should not be a problem, I think. એમાં તો ખાલી kq by r square જ કરવાનું, right? So આવી રીતે magnitude મળી જાય. And then you still have to find direction. Okay. Taqlif. The direction can be found by taking alpha here, and I hope you remember that if you have got two vectors, right? Sorry, not like this. if you've got two vectors and this is their resultant and it makes an angle alpha, right, with 1, okay, then you have a formula. Tan alpha is equal to b sine theta upon a plus b cos theta, right? Okay, so this is the formula that you have to use. So anybody alpha mari jase, right? By putting theta's value, b means second one, means EPB. A means first one, means EPA. How karwan, right? It is very long, okay. I will not hide that from you. આટલું તો ખાલી મને કેતા time લાગ્યો ને, right? So when you do it, it will take even more time, right? But there is no other way, right? There is absolutely no other simple way, right? Okay, fine. So we are already beyond 5 o'clock. Okay, so we will continue with this chapter later. All right, thank you all of you for being here till the end, right? Harsh, we will take your question the next step. All right, or you could send it to me personally, no problem, right? Goodbye everyone.